There are a few exceptions on spin multiplicity. These type of protons, they don't couple with anything else, and they don't even though they have neighbor, but they don't split. Okay, and these protons are the OH and NH, the one that have hydrogen bond, right? And we also have an aldehyde and a carboxylic acid as well, right? Oh, let's take a look right here. Okay, so first off, look at the proton. I want you to look at the proton right here, the green protons. First off, how many neighbors do they have? One neighbor from the OH, right? So it's supposed to be doublet, but actually this one shows a singlet, right? The hydrogen right here is exchangeable. I mean, it's acidic, so they can transfer with a solvent. So sometimes we call exchange with the solvent. So treat them like a ghost. Sometimes it's there, most of the time they don't. That's why this peak actually show as a singlet. They don't communicate. Okay, so it's supposed to be doublet. They talk to each other. They go, but hey, we're going to be doublet, one neighbor. But no, this guy actually doesn't. It's not really here. All right. Now, so the red proton, the from the OH, supposed to be a doublet as well, right? But it's actually show a singlet. Well, because so supposed to be a triplet because they got two neighbors, right? But actually show a singlet. Yeah, because it's not really there. The NH similarly. The NH, take a look. The two protons right here, how many neighbors? 1, 2, and then 2 more here. So 4 total, supposed to be 5p quintet, right? But then there's no quintet here. Right? No, actually show up triplet. They don't. These two protons do not couple with the exchangeable proton of the nitrogen. Okay. The nitrogen got two neighbors. The hydrogen on the nitrogen got two neighbors. Supposed to be triplet, but look what you got. You got a broad singlet peak. You know, so treat the acidic proton like a ghost. They are not really there. All right. In the molecules, they look like it's there, but in solution, it's not really. All right. Now one more: aldehyde and carboxylic acid. Okay. Start with this proton. How many neighbors do they have? Got one proton here, right? How many neighbors? 1, 2, 3, 4. Supposed to be quintet. What do you got? You got a quartet, right? Looks like this guy got only 3 protons, right? Just act like this got 3 protons. The reason is, well, the proton right here, they don't really couple. They don't really communicate. So this proton right here, you can treat it as if it got only 3 protons at the top. All right. This proton is supposed to be so next to got one neighbor, supposed to be doublet, but it actually shows singlet. Right there. Yeah, aldehyde 9 to 10 ppm, right there. You know, supposed to be singlet. So my point is, a proton of aldehyde, carboxylic acid, OH, and NH, they don't really couple. Right? In reality, they couple. They do, but the communication is really small. So you can see that the tip of this signal, the quartet right here, a little jack at the top. That's that actually split a little, but really, really small from that hydrogen. Right? Actually, they do, but too small, but you don't really see it. This peak is supposed to be doublet. If you can zoom in, really, really zoom in, you might be able to see a doublet. But like normally, we just see but that doublet is really, really small. You can't really see the split. So we just usually just a singlet right there. Okay, yeah, if you can zoom in, you can actually see a doublet there. The gap is too small. Look like a singlet. All right. All right. Now I want you to match each proton to its signal. Do on yourself by yourself first, all right, and then check with me. There are 3 types of proton. We have one, one here, 2 here, and 3 here. Start with the outside. Right. The outside is easy. Got one neighbor, so it should be a doublet. That guy right there. Right. The inside one. Now be careful. So 6 neighbor. Do not count the OH. Right. Treat this guy like a ghost. Okay. And so basically, this guy got only 6 neighbors, so show up septet, 7 proton. There we go. Lastly, the proton right here got only 1 neighbor, but again, this proton, the structure show is like it is there, but it's actually not really there, right? It's exchangeable with the solvent, so that's why right there, singlet right down there. Can't really see any split down there. All right. Next one, we have aromatic compound. All right, I'm going to label A, B, C, and D, so you have to match this. All right. So let's see what we got. Let's see. A, this by itself, right? Singlet. Use singlet. This proton right here next to the oxygen, so the chemical shift going to be about 3.7, all that right there. So we got that guy. Singlet by itself, no neighbor. D got one neighbor on C, so it's going to be doublet. All right. We have a doublet right there. That's a doublet, two doublet right. Yeah, two peaks, that doublet. This really difficult to see. We got two triplet right down there. Yeah, 1, 2, and 3 triplet. 1, 2, and 3 triplet. All right, C right here gonna be triplet. Got one neighbor, two neighbors, so triplet. All right, so C is right there, and D also a triplet. Got two neighbor, 1 and 2, so two neighbor also triplet. Okay. Now you might ask, why do I put C more D shielded than D? Here's the reason: because of the functional group up here, the oxygen. The oxygen can donate electrons. You can draw the delocalization resonance structures. Right? You can see that D is more D shielded, got high electron density down here. Right? So I'm going to guess that because of the oxygen push electron on up to proton D to this carbon. Right? So this position is more shielded, more electron density than C. That's why I put D to here, and C is the highest one. Yeah, all the one para are shielded. Right? If you look, so I look some things up on the internet. So look at the chemical shift. When you have the oxygen, right, the regular proton on benzene is 7.34. Right? The ortho and para are shielded. The ortho and para are shielded at less than 7. If you remember, the proton on the benzene is about 7 to 8, right? At 7.34. Now because of shielded go down to less than 7. At 7.29, this is normal chemical shift. Okay. All right, we're gonna sketch together. You have to be familiar with it. Let's sketch.